Discussed about the different traversal techniques, the pre-order, then in order, then post order. Okay, and then we discussed about the different properties of binary search tree, binary tree, not search tree. It's exactly the general properties for any binary tree. Then we have seen different types of binary tree, some terminologies related to binary tree, then how to draw a binary tree from uh, its uh, its sequence of traversal data. So we have already seen these things, and in this regard, there is another type of tree which is sometimes called expression tree. Okay, expression tree. So generally, expression trees are nothing but the representation of any expression in a form of tree. Okay, so generally we do this for infix expression. Generally, infix expression. So suppose this is one infix expression, a plus b into c. And if I want to draw a tree for this expression, if I draw a tree for this expression, then it will be called one expression tree. Now, when we are drawing an expression tree for a particular expression, normally in fixed expression, then you have to remember few things. The thing number one that you have to remember, that is the precedence of the operator. Precedence of the operator. You have to check the highest precedence operator first, and that will be in the lower side of the tree. Highest precedence operators will be at the lower side, or you can say as branch of the tree. Okay, so from this particular expression, this one having the higher precedence, so it will be in the lower side or lower branch of the tree. Okay, this is one thing that you have to remember, and according to that, step by step you have to create the tree. And another thing, for any expression, operator becomes the father and the operands become the children. Remember this thing. So you have to remember these two things. These two things are very important. Okay, so suppose a expression is written like this. Suppose mm, mm, r equal to a plus b into c. Now, so according to precedence, there are how many operators? There are one, two, three different operators. So according to precedence, this will be executed first, then this one, okay, and finally this one. So which one having the higher precedence? Highest precedence, obviously this one. So first we have to execute this. Means the tree will be created first the lower branches, then we will go upward. Okay, so and in the Second thing that you have to remember, operator in this expression, this is the operator into, so operator becomes the father and the operands become the children. Now the question is which one become the left child and which one will become the right child. Now since it is an infix expression, obviously the left hand operand will become the left child, right hand operand will become the right child. So it means my first picture will be like this for the first expression. Okay, this is for the first expression I have executed. Now see, this is, now this single thing become one operand, this single thing, suppose x. So now my next expression is a plus x. So this is my x, this is my x. Okay, so plus becomes the father. Okay, and this is x, this side is x, this one is x, so this will come in the right hand side and a will come into this side. Okay, done. So up to this done. Now suppose this becomes say x1, so this total thing now is my x1. So now my new expression is r equal to x1. So this equal becomes the father, this is because this is one operator, this x1 which is in the right hand side and r in this side. So this is your expression tree, this is your expression tree. So I hope it is clear. Very simple to draw an expression tree. Now see, if you are able to draw this expression tree, from this you can easily calculate or easily able to get the prefix expression and postfix expression. How? If you have this picture of expression tree, then from that you can easily measure the prefix and postfix expression. How? For prefix we will do the pre-order traversal and for postfix we will do the post-order traversal. Now please tell me what is the postfix and prefix for this particular expression. Please, anyone, prefix. So you have to start from this root, this is the root, you have to start from this, and prefix means when I am visiting the nodes from left hand side or first time, you can see this also can be uh, measured or calculated from this thing, that when I am visiting it from this side, this is the first time I am visiting. From this side when I am visiting, it is the second time. From this side when I am visiting, it is the third time. So when I am visiting it from first time, if I print it, I will get pre-order. When I am visiting it second time, if I print it, I will get in order. When I am visiting it third time, if I print it, I will get post order. Or you can say, if we visit the node from this left hand side, we will get pre-order. When we are visiting the node from the bottom side, we will get in order. When we are visiting the node from the right hand side, we will get the post order. Now please tell me, what is the pre-order or prefix for this particular expression? So I am moving from this. So first equal, then r, okay, then plus, then a, then star, then b, then c. Done. Okay, this is the prefix. Now what is the postfix? Postfix is when I'm visiting it from the right hand side. So no, first r will come, r, then a, Okay, so what is the next, please? Anyone? After A, what is the
স্যার
next?
বলছি স্যার আর এর পরে এখানে ইকুয়ালস টুটা বাদ দিয়ে তারপরে স্কিপ করে ওটা এ গেল কারণ ডাইরেক্ট?
কারণ আমি তো পোস্ট ফিক্স করছি, পোস্ট ফিক্সে তো নিয়ম হচ্ছে যখন আমি রাইট হ্যান্ড থেকে ভিজিট করব, ইকুয়াল টু কে আমি তো ভিজিট করলাম তলা থেকে, হলো না তো?
আচ্ছা স্যার, আর প্রিফিক্সটা স্যার বলবেন? প্রিফিক্সটা তো
প্রিফিক্স হচ্ছে
স্যার
যখন আমি
মাঝখানে
লেফট হ্যান্ড সাইড থেকে যখন ভিজিট করছি, এই যে
আচ্ছা
এই যে ইকুয়াল টু এলো, আর এলো,
আচ্ছা
তারপরে এই যে প্লাস এলো, এ এলো, তারপরে এই যে যাচ্ছি ইনটু এলো।
বুঝতে পেরেছি।
আর পোস্ট ফিক্স হচ্ছে যখন রাইট হ্যান্ড সাইড থেকে, দেখো এই যে যাচ্ছি, এখনো রাইট হ্যান্ডে করিনি, এই আর কে প্রথম রাইট হ্যান্ডে করলাম, আর এলো, তারপরে যাচ্ছি যাচ্ছি যাচ্ছি, এই এ কে প্রথম রাইট হ্যান্ডে করলাম, এ এলো, যাচ্ছি যাচ্ছি যাচ্ছি, তাহলে এরপরে রাইট হ্যান্ডে করলাম বি কে, তাহলে বি আসবে, তারপরে যাচ্ছি যাচ্ছি যাচ্ছি, এবারে সি কে প্রথম রাইট হ্যান্ড দিয়ে করলাম, সি এলো, তারপরে রাইট হ্যান্ডে করলাম ইনটু, প্লাস, ইকুয়াল টু, পরপর চলে এলো ইনটু, প্লাস, ইকুয়াল টু। আর যদি ইন অর্ডার পড়তাম, ইন অর্ডার পড়লে তো তুমি ইনফিক্সটাই পাবে, যেটা আমার অ্যাকচুয়াল এক্সপ্রেশনটা কিরকম হবে। ইন অর্ডার মানে হচ্ছে আমি তলা দিয়ে যখন পড়বো, তাহলে প্রথম হচ্ছে আর, তারপরে তলা দিয়ে ভিজিট করলাম ইকুয়াল কে, তারপরে যে যাচ্ছি তলা দিয়ে ভিজিট করলাম এ কে, তারপরে যাচ্ছি তলা দিয়ে ভিজিট করলাম প্লাস কে, তারপরে যাচ্ছি তলা দিয়ে ভিজিট করলাম বি কে, তারপরে যাচ্ছি তলা দিয়ে ভিজিট করলাম স্টার কে, তারপরে যাচ্ছি তলা দিয়ে ভিজিট করলাম সি কে, ব্যাস কমপ্লিট। দেখো এইটাই আমার এক্সপ্রেশনটা ছিল, এই এটা তো ইনফিক্স পাবো ইন অর্ডার পড়লে, ঠিক আছে। সো দিস ইজ কল্ড দ্য এক্সপ্রেশন ট্রি।
বুঝতে পেরেছি।
Okay, now the next thing that we are going to discuss today, that is our heap. Now I already told that this heap is this is not heap memory. Remember this. This is heap data structure. This is one kind of structure which is in a form of tree. Okay, so basically there are two types of heap. One is called max heap and another is called mean heap. Okay, now what is the exact definition of heap? So the first thing that you have to remember about heap, I have already told in the last class, that heap is a kind of complete binary tree. Complete binary tree. Now if you remember the last class, that what is the meaning of complete binary tree? Complete binary tree is a tree where every node having maximum number of children except the last level, or you can say every level having the maximum number of children except the last level, and the tree nodes in the last level will be as much left as possible or as far left as possible. It means if I am going to create a complete binary tree, then we can have some definite structure for that complete binary tree. What is the definite structure of the complete binary tree? The definite structure of the complete binary tree is it will be created level wise, left to right. It will be created level wise, left to right. So this is the actual creation or structure of the complete binary tree. So heap is one kind of complete binary tree. This is first definition. Then if it is a max heap, then if so both heap is complete binary tree. This is the first thing. Then there are two different types of heap. If it is a max heap, then the definition will be like this: father is greater than its children. Now, don't make confused with the binary search tree. In case of binary search tree, the picture is like this: if this is father, then it should be greater than its left child, okay, and it should be smaller than its right child. This is the definition of binary search tree. There is no duplicate element, no duplicate elements. Okay, this is another important thing. So this too for binary search tree. But in case of heap, if it is a max heap, the definition is father is greater than left child and right child. Okay, this is first thing. And the second thing is there is a possibility of duplicate elements. Duplicate elements can be present. থাকতে পারে, can be present. Now the question is, why in case of binary search tree no duplicate elements are allowed? Because in binary search tree what we are searching key values. Key values are always unique. Key values are always unique. You will understand this more about this key values in your most probably fifth sem in DBMS, database management system. So in database management system, we generally store one key value which is unique, and based on that key value we can search any element. So for example, my phone number or everybody's phone number is a key value because two person cannot have same phone number. Similarly, for you students, your student ID number or your student university roll number is unique. Based on that unique university roll number, anybody can search you. Okay, so this is called key value. So key values cannot be duplicate. That's why in binary search tree no duplicate elements are allowed. But heap is actually is for storing some data. Okay, that's why it is not storing key values, so there may be some duplicate elements. Okay, so what is the definition of max heap? The definition of max heap is it is a complete binary tree, first thing. Then for max heap, the value of the father node is greater than its children. And obviously, what is the definition of mean heap? Father is smaller than its children. Okay, it means in case of max heap, root element is the maximum element, and in case of mean heap, root element is the minimum element. Okay, now we will discuss how to create, how to generate a heap. So heap data structure is clear. It is a complete binary tree. Okay, and another interesting thing, since it is a complete binary tree, we have already discussed in the last class that complete binary tree or full binary tree have no wastage if we represent them using array. Okay, so that's why we can easily implement heap using array without any wastage, and that's why there is one sorting technique which is called heap sort. I hope now it is clear. Although heap is a tree data structure, but still we can perform or we can sort them. Why? Because we can easily implement heap using array. Clear? Because it is complete binary tree. Okay, now first we will discuss the creation of heap, then deletion of heap, these two operations, then we will easily understand how this heap sort is performing. Okay, so first thing that we will discuss is heap creation. This is very interesting. Heap creation. Okay, suppose I have some set of values for creating a particular heap, then how to create the heap, that we will discuss today. So suppose the elements are like this. Let's assume uh, say 25, 11, 32, 75, 62, then say 5, then say 82. Suppose I am going to create a heap with this data. Okay, so just first understand how to create. So first element, so according to the rule, the first element always become the root. So 25 become root. Then comes the next 11. Now, since heap is a complete binary tree, so first we will try to make a complete binary tree, then we will check the property of the heap. Now, suppose I am going to draw a max heap. Okay. So first I will add this 11 to make it a complete binary tree. 25. So we already know that complete binary tree always created from left to right level wise. So first level done, level 0 done. Now the second level, level 1. So first I will add it in this position. Now it is complete binary tree. Now the next thing that I will check, is it satisfying the max heap property? Now see here 25 is greater than 11, father is greater than children, so it is satisfying, so it is okay. So I will move forward for the next data. 25 done, 11 done. Now I am going for 32. Now first I will add it to make it complete binary tree. So now for complete binary tree, it should be added into this position. Okay. Now the next thing that I will check whether it is satisfying the max heap property or not. Now see here, this right hand child is greater than this right hand child, so you can write it here that 32 is greater than 25. Okay, so right hand child is greater than father, so it means it is not satisfying the property of max heap. So what I will do, I will interchange, I will swap this data values. It means 32 will come here, so you can write here swap, so 32 will come here, this side 11, this side 25. Now it is a complete binary tree and it is satisfying the property of max heap. Done. Next data 75. So first I will add 75 to make it a complete binary tree. So for complete binary tree, it will be level wise left to right. So first it will be added into this position. So 32, 11, 25, 75 will be added into this position. Okay, now I will check whether it is satisfying the property of max heap or not. Now see here, children is greater than its father, so you can write it here 75 greater than 11. Okay, then again, so you can write the step or you can jump it. It depends on you. You can directly jump, because you know that after 75 compared with 11, if we interchange, then 75 again will be compared with 32. So you can directly draw the picture or you can do it stepwise. So stepwise, this two will be interchanged first. So you will get a picture like this: 75, So better you do step by step. Again here write 75 greater than 32. So again swap or interchange. So then it becomes 75. There comes 32, 11, this side 25. Now again it is a max if. Done. Next is 62. So 62. This 62 will be added into this position. Okay. So 75, 32, this side 25, 11, 62. Now again 62 is greater than 32. So interchange. So this two will be interchange. Now the picture becomes 75, 62, 11, 32, 25. Okay, done. Now 5 will be added into this position. So 5. So the picture becomes 75, 62, 25, 11, 32, 5. Now 5 is smaller than, so it is massive. Then comes the 82. So when I will add 82, it will be added into this position. So it becomes 75, 62, 25, 11, 32, 5, 82. Okay. Now 82 greater than 25. So interchange. This two will be interchanged. Picture becomes 75. Okay, I'm drawing it directly. Then 82 again greater than 75. So I'm writing it directly here. 82 will come here. 75 will come here. Here comes the 25. This side 5. This side 62. 11. 32. Done. So this is your max heap. So this is the max heap creation. How to create max heap? Again, step by step. First, you have to make complete binary tree. So if we write the algorithm of this heap creation, then we will write it like this. Add the new node. Add the new node to make it complete binary tree. Then the next step is adjust the node, or you can say newly added node to its proper position by interchanging. So this is the steps of creation. These steps will be repeated for each and every element, for every new element. You have to do this. So this is the heap creation. Very simple. Okay. But if you want to represent it in array, then I will show you how to represent. First, this is the heap creation. Then comes the next thing about heap, that is the deletion. Deletion of heap. Okay, now deletion is pretty interesting. Why? In case of heap, we can only delete element from root. That is the most interesting thing. In case of heap, we cannot delete any particular element. There is a particular position from where we can delete. Normally, how to delete? Suppose I am going to delete some element. So in that case, I will search the element, then I will delete. But if I say delete from stack, then delete from stack means you have to delete from the top of the stack. Okay, when I say delete from queue, then you have to delete from the front end. Similarly, in case of heap, deletion is always performed from the root position. So we can delete element from root. So root element will be deleted, and and it will be replaced by the last element of the heap. Okay, then the next step is adjust the heap. So this is the step. Now what is the meaning of this step? Just try to understand from this particular example. So example 80, so for this particular example it is 82, then this side 62, 75, 11, 32, 5, 25. So I'm starting deletion. So what is the algorithm for deletion? Delete the root element and replace it by the last element. Which one is the last element in this? This is the last element. Okay, because we cannot delete this one. Why? If we delete this one, it will not be a complete binary tree. So in complete binary tree, in which position we have inserted last? This is the last position. So what we will do, we will replace this with the value of this. Before that, we will delete 82. So we have deleted 82, and this one is replaced by 25. So your picture will be like this. So here we will write delete. So here comes 25. Okay, and the rest is like this: 62, 11, 32, this side 75, this one 5. Okay, now what you have to do, next step, you have to adjust. See, this is no more max heap, so you have to adjust. How to adjust? So there comes a pretty interesting algorithm. So how to adjust? So this is the node, that this node you have to put this node in its proper position, because this is now in a bad position. Now you have to put it in proper position. So what we will do, so this is the father root node, this is the father. Among its children, the left child and right child, among this children, what I will do, I will go for the children which is the maximum one. So among this left child and right child, which one is maximum? This one is the maximum. So I will set this one as max. Then what I will do, I will interchange this two element. Okay, then I will get the picture like this. 75 will come here. Okay, here comes 62, there 25, 11, 32, 5. Okay, now see, this 25 got its proper position. Now 25 is the father, its children is 5, so 25 got its proper position. Now it becomes again a perfect heap. Next, again deletion. If I delete from this, what will happen? Deletion means I will get 75, so I am storing them. Next deletion, I get 75, I will store it in this way. And which one will replace this? Obviously 5 will replace this. So what I will get from this? I will get 5 in this topmost position. Then in this side 62, this side 25, this side 11, this side 32. Okay, again it is not, so you have to write here adjust. So here delete. Now you have to do the same thing, adjust. So what is the logic of adjustment? Among this left child and right child, which one is maximum? This one is maximum. So compare with this and interchange. So after interchanging, we will get 62 in this position. Here comes 5, here 11, 32, and in this side 25. Now see, still 5 not got the proper position. Again this left child and right child, which one is maximum? This one maximum. It will be compared and interchange. Okay, so what you will get? You will get 62 at the top, and here 32, this side 11, this side 5, this side 25. Again it is a max heap. Okay, so now again I will perform the same deletion. If I delete this time, I will delete 62. So now I got 62. Okay, to see the sequence. Clear? So which one will replace this? Obviously the last one, this is the 5. 5 will replace this, so I will get 5 in this position, then 32, then 25 here, 11 here. Done. Now I have to adjust among this left child and right child. This one is maximum, so it will compare with this and interchange. And what I will get? I will get the next picture, that is 32 in this position. Here comes 5, this side 25, this side 11. Still 5 is not in proper position. This is the only left child, and this one is greater than this, so this two will be interchange. Okay, so after that I will get 32, this side 11, this side 5, this side 25. Again I will perform a deletion. Okay, so this time which one will be deleted? 32, and which one will replace this? 5. So I will get 5 here, this side 11, this side 25. So the deleted element is stored in this position 32. Okay, now next again I will adjust, because this is no more a max heap. So among this left child and right child, this is the maximum, so this two will be compared and interchange. So 25 will come here, 11 will come here, 5 will come here. Then again delete, so now this time which one will be deleted? 25. So 25 is deleted and stored into this position 25. Okay, now and which one will replace this 25? Obviously 5 will replace this 25, so I will get 5 here, and in this side 11. Again this is not max heap, so I will interchange. I will get 11, this side 5. Again I will perform another deletion. Okay, so if I